So in this video we're starting the question, what is function? So let's try to analyze the meaning of function. Let's try to understand what is function. Okay, I'm going to give you an example that will clarify the meaning of function. Area of a square, we know the form of area of a square. Area of a square A is equals to L square, where L is the side of a square. Okay, now let me make a table. We have value of L and here we have A. Now if we change the value of L, suppose if we take the value of L 1 unit, the area will be 1 unit square, so it will be simply 1 square, that is 1. Similarly, if we take 2, it will be 2 square, so it's gonna be 4. If we take 3 square, that is going to be 9, and so on. We can continue. Now from here we can see there is relation between L and A. Okay, if we increase L, if the value of L is increased, we can see that we have increased the value from 1 to 2, and when we do that, the value of A has been also increased. It has increased from 1 to 4. Okay, so when L increases, A has also increases. Or when we decrease the L, okay, when we decrease the L, A also get decreased. That means A depends on A depends on L. Okay, so I can write this here: A depends on L. Now see, mathematics are the people living in the fancy world. They like a very unique kind of terms. They want to have their own rules and own kind of word. So instead of using this depend on this word, they use a fancy term, okay, a fancy word, and it is the same statement can be said in this way. So A is the function of L. Okay, A is the function of L. Now if you write mathematically in a mathematical statement, we can write like this: A is the function of L. Now see, this could be look a bit different, but there's nothing. It's a very simple way of saying that A depends on L. Okay, this is much more powerful, much condensed form, and to a general people it will be confusing too. Okay, now this is read as A is function. Okay, for function I'll already denote with this fn as to save time. A is function of L. So we read this as A is function of L. Now function, they can be understood in two ways. If we try to understand function, I'll try to explain in function in two ways. Okay, function as a rule, we can understand a function as a rule, or you can also sometime you'll find over there correspondence, correspondence, function as a correspondence or function as a machine. Okay, so let's talk function as a rule or correspondence. Okay, for the first concept, this is the A, so I'm starting with A. Now for this, let's consider we have two sets. Okay, we have two sets. This is capital X and we have another set, this is capital Y. Consider the element of set X as x1, x2 ... like that, and similarly the element of Y to be y1, y2 ... like that. Okay, now suppose we have a rule, okay, and that rule makes the connection, okay, between element of set X to the element of set Y, okay, such that now there's a condition. Okay, now they are related. For example, x1 is related to y1, x2 is related to y2, and maybe there is a x3, so they are related. Okay, now the relation, there is a unique rule, there is a rule. Okay, and what is so specific over here is that now for every x1, okay, for every x1 there is a unique y1. Okay, now what do I mean to say that for every x1 there is unique y1? Now let me give you two examples. Okay, suppose we have the element x1 and x2 from the set x, and we have the element y1 from the y. Suppose that this is connected to it and x2 is also connected to y1. Okay, so this is one case. The next case can be there is one x1 and this x1 is connected to y1, and this x1 is connected to, sorry, this must be y2. Okay, it is connected to y2. Now if you see from the rule of function, this is valid. Okay, we say this is a function. Why? Because this x1 is connected with only one element of y, that is y1. Okay, it has unique element that is connected to of y. Similarly, x2 is also connected to a unique element that is y1. Okay, for this it doesn't have other. Okay, but if you see in this example over here, this x1 is connected to y1 and this x1 is connected to y2, so it has two connection. It is connected with two. Now there it is not unique. Okay, now what we say, now the x1 must have only one destination. I'll say that. Okay, it must have only one destination. Now we know the meaning of destination, the end goal. Okay, there must be only one destination. Now if you see for x1 it has only one destination, that is y1, but over here if you see the x1 has two destination, that is y1 and y2, thus the destination is not unique, so this is not a function, so we don't consider this as a function. So function can be defined as a rule. Okay, as a rule that associates, that means that connects. Okay, that associates element, that associates element in x with some unique element in y. Now I forgot to say that that associates every element. Okay, that associates every element in x with some unique element in y. Now what do I mean to say that every element in x must be associated? Okay, to clarify this, I have made three examples. Okay, if you see in the first example, x1 is connected to y1, x2 is connected to y2, x3 is connected to y3. Clearly you can see that each element is associated with unique element in y, so this is a function. Definitely this is a function. Okay, in second case, if you see over here, x1 and x2, they are also connected with the element in y, so they both have a unique element in y, so this is also a function. We also consider it as a function. But if you go in the third case, okay, now x1 is connected to y1, it has a unique, x2 is connected to y2, so it also has a unique element, but the x3, it has no, there is no element for x3 in the set y, so this is not a function. We don't consider this as a function because every element, so you have to see over there's the word every element in x must be in connection with some element in y. If that doesn't happen, so that will not be considered as a function. So I hope this has given you some insight regarding the function. In next video I'll talk about function as a machine. Okay.